In section 3.7 called Implicit Differentiation, you're going to learn about two different things, and one of the things you actually already know, so that's a comfort. Implicit differentiation, however, can be tricky until you realize exactly what hoops you have to jump through to get these right. So let me first remind you what the word implicit means. Implicit means that there is implied in here a couple of different functions. This is actually not a function all by itself. If you remember from last year, this is an equation of a circle that has a radius of 4. So it's actually a circle. This is y equals the square root of 16 minus x squared. And all I did was solve for y. I subtracted x squared on both sides and took the square root. And then there's also the lower function. This would be, like in your calculator, this might be y1, and here's y2 would be the negative square root of 16 minus x squared. So if you want to draw a circle in your calculator, that's the way you have to put it in. This statement has both the red and the blue implied directly within it, and our goal in calculus is to figure out slopes of tangent lines often. So we might have to find the slope there, and we would need to locate that point with an x and a y, by the way. Or maybe we want to know the tangent line slope down here. And by the way, it looks like I just drew some parallel lines. So we need that coordinate. We need an x and a y. So our goal in 3.7 is to learn how to find the slope machine, called the derivative, in a situation where the relation we've been given is not a function. It has functions implied within, but we can still find the tangent line slope. All right, so let me walk you through this one real quick. What you need to realize is the variable y is going to represent our dependent variable, our f of x. And we learned in last section, whenever you take the derivative of a function, like an inside function, you need to tack on the f prime, it's called the chain rule, to the end of it. So here's what we're going to do. We're going to take the derivative of each piece's part separately. So the derivative of x squared would be 2x. Now the derivative of y squared would be 2y. However, remember, y is a function. It's an inside function. In this case, y is the square root of 16 minus x squared. So what we're going to do is we're going to tack on the derivative of y. That's called the chain rule. Just don't make it any more complicated than whenever you take the derivative of something that has a y in it, you have to tack on a y prime. Equals, then take the derivative of the right side. Now a lot of students mess this up because they accidentally write 16, but of course the derivative of any constant is 0. All right, we're actually really close to the answer. Our goal here is to have y prime equal and then have the answer on the other side. So what we have to do is subtract 2x on both sides. And we get 2y. Y prime equals negative 2x. We then divide by 2y. And we get negative x over y is y prime. Negative x over y prime. So this is actually dy dx. Remember, that's the same thing, same notation as y prime. Negative x over y would be the answer. All right, let's go to the next screen. So what do you notice about this derivative that's different than what we were doing before? And what's different is the derivative is not just a function of x. It actually is also a function of y. So you have to know the entire coordinate, the x and the y, to find the tangent. And we talked about that. If I want to know the tangent slope here versus here, I'm going to have like 1 comma 3 versus 1 comma negative 3. So I'm going to get a different slope depending on a different point that I plug in to this guy up here. So you need to know both the x and y so that you can figure out the slope of the tangent line. So the derivative has an x and a y in it. That's what's different here. All right, sometimes you have to do some special algebra steps, so you may have to watch this one a couple times. You're going to do this many times throughout the year. And we did this a little bit last year in preparation for this. So let's take the derivative implicitly. That's what this is called. We're taking the derivative implicitly. We do it in pieces parts. The derivative of 2y is 2. The derivative of y is just 1. However, we're taking the derivative of a y term, so we have to tack on a y prime, equals the derivative of x squared is 2x. No x prime needed because x is just your dependent variable here, or your independent variable. So no need to tack on an x prime. Plus, all right, here we have the derivative of sine is cosine, and what happens on the inside is that the y stays the same, of course. However, we have an inside function called y, so we're going to tack on a y prime. All right, now I want you to notice we have a couple of y primes floating around. So before we actually go on, let's write out the steps here, what we just did. We took the derivative of all the separate terms, there were 3 of them, on both sides. And careful to add on that y prime, not add on, but multiply by y prime whenever you're taking the derivative of something that has a y in it. All right, now the next step. We're trying to solve for y prime, so what we do is we move anything that has y prime in it over together on one side, maybe the left side. So let's write that down. So we're going to move anything with y prime to one side. We're going to minus this entire term. This is called a term. It's like, 3x. We would minus 3x on both sides. We're minusing minus cosine y prime on both sides. So now we have 2y prime minus cosine y prime. And that y prime is not inside the cosine, by the way. Only the plain old y is inside the cosine. Equals 2x is still left on the right side. All right, so we're getting ourselves ready to do the next step, which is to factor out the y prime on the left side. We have a GCF here. We have 2 terms, and they both have a y prime. So let's extract it out. Let's divide it out. It's called factoring. 2 minus cosine y is left on the inside equals 2x. Now we are really close to the answer because now you simply solve for y prime. Dividing by the parenthesis, this number, or this expression. This is an expression, and when you divide by a factor, the entire factors will cancel on the left side, and it appears in the denominator on the right side. So there is our answer. Y prime equals the fraction 2x divided by the quantity 2 minus cosine y. That's your slope machine. So let's just review real quickly. You take the derivative of all the separate terms, move anything with y prime to one side and everything else to the other side, extract out or factor out that y prime, and then solve for y prime by dividing by the parenthesis on both sides. You're going to do this over and over again on these implicit problems. So come back to this slide if you're having troubles remembering how to solve for y prime when there's a bunch of y primes floating around. All right, here we have a relationship. X times y is always 10. X times y is always 10. And we want to find the derivative at the point 2, 5. Notice we have an x and a y location. And we do take this derivative implicitly. And we have to remember the product rule here because we have something, x, times something else, y. So we're going to take the first times the derivative of the second plus the second times the derivative of the first. That would be y times 1 equals the derivative of 10 is 0. So let me just rewrite this. Well, this is pretty easy. Now all we have to do is solve for y prime. Solve for y prime, and there's only one floating around in this problem, so I'm going to minus y on both sides. I get x y prime equals negative y. Divide by x. You get your answer. Y prime dy dx is the opposite of y over x. Now, be very careful when you plug in this. We're going to plug this information in. Y is 5 and x is 2. So, when we plug that in, dy dx would be negative 5 over 2 is the slope of the tangent line on the relationship x times y is always 10. All right, let's move on. Now, how about finding a second derivative? That's what this notation means. I'm not even sure how to pronounce this other than to just recognize that it's the second derivative where y is your dependent variable and x is your independent variable. So we're going to take the derivative implicitly here because we have a y intermixed in with the x's. So I'm going to throw the 3 out front. I get 6x squared minus 6y. And then we just took the derivative of a term that had a y in it. So we tack on the chain of y prime equals 0. Now, I think it's best here to maybe solve for y prime at this point. Remember, we're trying to find the second derivative, so let's go ahead and finish solving for, I'm going to minus 6x squared on both sides, and then divide by negative 6y, and I get y prime is x squared all over y, positive. Alright, so then we take a deep breath, and we're going to take the derivative again. Now stay with me here because there is a trick at the end that you need to be aware of. Now, in the interest of saving room here, I'm going to start up here. So y prime is x squared over 9 over y. Okay, so how do we take the next derivative, which is the second derivative? Hopefully you're thinking the quotient rule. So we start with the bottom, which is, it's the denominator times the derivative of the top minus the top times the derivative of the bottom, which is y prime here. 1y prime. Not y prime, because the derivative of y is just 1. But we have to tack on a y prime because we took the derivative of something that had a y in it, all over the denominator squared. Alright, so I'm going to rewrite this now because we might think that we're done. We're close. All over y squared. Now, what do you think we have to do at this point to just finish up this problem? We need to swap out this y prime and put this guy in there. So this is the little trick at the end you need to remember. So the answer is 2xy minus x squared times x squared over y all over y squared. And of course that's kind of a algebraic mess. I guess you could leave your answer like that at this point, or you could multiply these fractions straight across and add up everything. And let's see, you're going to get, this will be x to the 4th over y, and then to subtract those fractions on the top, you would have to get 2x y squared minus x to the 4th. Now, they have a common denominator. What I did here is I upgraded that like that. They have a common denominator that's y, and it's in the bottom. So that will, when we do keep, change, flip, fold in with that guy and get all over y to the 3rd. I don't have a lot of space to work out all my work there, so hopefully you followed that. Ask me in class if you need me to clarify the algebra that I just did there. But this is probably the best way to write it. If it were multiple choice, that's how they'd write it. Looks a lot better that way. Right, at the beginning of this video, I said that you'd be learning 2 different things in this section. You've learned about implicit differentiation and, frankly, how easy it is, right? Whenever you take a y, derivative of anything that has a y in it, you just tack on a y prime. That's all there is to it. Now, this is another power rule that we've already actually been using. First thing you do is rewrite it as a fractional exponent. That's called a rational exponent. So remember, what's up high goes up high. The roots are underground, so they go down low. Okay, well, what do you think you do? Well, it's just the power rule. You throw the exponent out front, the base stays the same, and then you have to add -1 to the exponent. So that's the same as adding -3/3. So you get -1/3. And there is no inside chain here to chain on. So the answer is 2 over 3. Now, because this exponent is negative, it's going to travel down below. So the base x is going down below. And what does an exponent of 1/3 mean? It's the third root of x. So this is one way to write the answer. Now remember, sometimes we like to get rid of the roots in the denominator. Now sit up straight and listen on this one, because this is a third root. We do have to do something a little bit differently. We have to create a perfect cube in the bottom, which means we're going to have to introduce two factors of x down there. This is called rationalizing. So we get 2 third root of x squared on the top. I think you probably follow that. You might still be scratching your head why I'm using x squared. Well, just pay attention and you'll get it here. 3 is down there. We have the third root of, now look here, I've introduced 2 more factors of x to go with this guy. So now I've got x to the third, and that's a perfect cube, which is what we needed. So this would be 2 third root of x squared all over 3x. So you learn something new every day. Isn't that exciting? So that's all there is in section 3.7, implicit differentiation. Practice, practice, practice. Whenever x's are intermingled with y's and it's not very easy to solve for y, you got to do it implicitly. And then also this rational power rule. All right, practice, practice, practice on that implicit differentiation. That's often tricky for students until they get the hang of it, and then they realize it's really not too bad. And that's pretty much true for all things in life. So good luck. I'll see you in class.